So I'm hoping that you have been having fun in the last 2.5 days. And today, finally, you can enjoy this nice, sunny Seattle today. It's like that, by the way, outside today. So I'm going to talk about IoT security. And before I do that, just to remind you that IoT is actually real now. Last year and the year before that, we were all thinking about how real is IoT and how can I actually get my hands around it. But now we see real deployments happening. We see businesses transforming themselves with IoT. And people are actually realizing some of the upsides of IoT, of using IoT. But then, while all of that is happening, businesses are also realizing that there is a huge security risk that they need to think about. And so today what I'm going to do is I'm going to talk about some of those risks and then talk about the things that we, Microsoft, are doing to help you build more secure IoT solutions. So that's the goal here. And I only have 20 minutes, so most of the content I'm actually going to point you to things as well. So I'm going to give you some homework when you go home. But a bunch of things I'm going to just highlight here and then point you. I'm Arjuman Samuel. I am a program manager on the Azure IoT team, and I lead security for the team. No IoT security or security talk would be complete without giving a really nice hack story, right? We need to actually have that story. So here is that story. I'm sure we have all heard of that. Mirai? Yes, we have. So this is an attack which happened late last year, October or so. The fun part here is that this attack was an IoT-centric attack. Probably the first IoT-centric attack at that scale. So a malware took over a bunch of cameras and DVRs, and these were all small little devices all around us, and then created a distributed botnet, and then started attacking some key infrastructure level sites on the internet, and actually brought down a bunch of those, right? And so the key vulnerability there was a very, very simple vulnerability. Most of these devices, these small little devices, their admin password was admin blank or admin123. And there was no way or either to change that password, or there was no instructions when consumers were putting them up that they should actually change those passwords to something stronger. So all you needed was to go in, look for that signature, and then start attacking or taking over that device. That happened to 500,000 devices, but you can read a lot about Mirai. I won't go into details of all that is happening with it now, but I'll just make 2 points here. The first point, I haven't seen a massive recall of my DVR or our DVRs and IP cameras and other IT devices, which actually means that vulnerability is still around us, waiting to happen again, right? So that's still around us. That's just something to think about, that it's not that it's gone, but it's that nobody's using it and somebody might use it. Which brings me to the second point. The second point here is Mirai malware, both the control system as well as the stuff that sits on these devices, is now open sourced. If you know where to look for it, you go in, you can get that. Don't do that, by the way. But you can get that, and you can actually start playing with it. And I get worried that somebody in their garage is actually toying around with it and making it much more lethal. So those 2 points, IoT security is top of mind for all of us, not just because of this, but because of a bunch of other things as well. I won't go into all of those, but I'll just now start talking about what are we doing to mitigate that. The first thing, I'm sure any security speaker would tell you, IoT or any security, IT security, or even physical security is always a journey. It's not an end. It's not a goal that you achieve and you're done. If that is what we are thinking, then we are not secure. So we always constantly have to continue working on it. Cost of security has gone up. Security breaches have gone up substantially with IoT, because now these are physical devices which we are talking about. These are not only IT systems. These are not only databases and apps we are talking about. These are physical systems, robotic arms and such. And the worst part there is these physical systems can actually cause real physical damage. They can also cause loss of life. Right? So IoT security, the cost, not just in dollar terms, but generally the cost has gone up substantially. So we need to think about it slightly differently. And then imagine that, example I talked about, the Mirai example. It's not a matter of if it will happen to my infrastructure. I think it will happen. It's about how prepared we are to deal with security breaches and what we will do after it happens, not just to us, but others, and how we can actually deal with it. So our key takeaway from, if there is one takeaway that you can take with you when you go and see beautiful Seattle, it is that for IoT security, you have to think about it end to end. You cannot just have the cloud being secure, which it is. If you're using Azure IoT, you have a secure cloud on your side. But then the device that is connecting to the cloud also needs to be evaluated. You also need to look at everything in between from where data is generated all the way to the cloud. And if you can say that it is secure, only then your end-to-end IoT solution is secure. Here is an example. So this is a camera, a very standard IP camera, which you can buy for like $50. In there are components which nobody can stand by and nobody even understands. The silicon on it might not be as secure as we think. There might not even be a hardware-based security on it because cost was a premium there. The OS on it is unknown. Many times they'll take a standard open source OS and then they'll bring it down to its bare minimum because there is a constraint on hardware, and they'll run on it. What happened to all the security checks built into that OS? Nobody knows. Is this machine or is this device configured to be updated from the cloud or from outside? Probably not. And if you have deployed hundreds of these or millions of these devices, you can't run around on a truck and update them manually. So having that feature set into it is usually not possible. And then physically, somebody can always take it out and play around with it. So if you have answered no to any of these questions, obviously you're not secure. And this was just one example of how bad right now IoT security is, because if this device is not secure, end-to-end IoT security is not there. So the question then becomes, okay, what do I do with it? So here is one way of thinking about it. This is one way of thinking about it. The people who make these actual devices, the widgets, in some contexts they're called operational technology, OT people, the people who make widgets, and the people who are actually responsible to do IT security are two different worlds, right? They talk two different languages. And what we have learned while we are working with our customers and our partners is they don't understand each other. And so there is a ton of security vulnerabilities introduced because of this mismatch. And I'll just give you a few examples of how that works. Imagine there is a shop floor, a manufacturing floor, where there are these PLC controllers. And now because of IoT, the coolness of IoT, you've connected them to the internet. And you're collecting a bunch of data. Now you have opened up this vulnerability for somebody to crack into your PLC controller and write in some malicious code into the PLC controller. Now your physical world is being attacked because your IT world could not be protected or was not protected in the right way, right? So you could actually have machine sequences being controlled. You could have the reliability of the machine gone down. And you would have created this system which would, as a whole, be insecure. And of course, many businesses think about the confidentiality of their IP and data, right? So if you are not careful when you connect an IT system to your actual physical widget system, your OT system, you have actually created an environment where there is an opportunity for that also to be stolen. Just a few examples of how this merger of this physical world and this virtual cyber world is creating an opportunity for a lot of security breaches. So the first thing we like to talk about is secure by design. How do we ensure that we have the right pieces in our end-to-end solution which gives you the right security at each part of your infrastructure? I'll start with the device. security, and then there is this cloud security, connection security, the networks that we have which enable data to come from the devices to the cloud, and then we have the cloud. Now in the cloud, there are a bunch of different things, just to, so you guys can take a picture. There's a bunch of different things you can do. For example, you could encrypt your data at rest, so that when it is at rest, at least it's encrypted, and nobody else has access to it. You could do a bunch of things with Active Directory. There are a bunch of talks in the last couple of days which talked about that. Key Vault is another technology out there which can be used to secure your keys and your certificates. You could do policy-based access control based on keys that IoT Hub would generate. And then you would also have advanced features like, can I block this set of IPs, or can I allow this set of IPs, and so on. So the cloud is probably, in this whole picture, the most controllable entity that you're dealing with, because there are a bunch of different things you could do. You could build defense in depth for the cloud. But when we start talking about the connectivity, that is another different ball game, because now you're talking about encryption on wire. You're talking about how does this data come from the device to the cloud. We support TLS and X509 based handshake between the devices and the cloud based on the SDKs that we have for each of the devices, each of the different platforms and languages. Now, coming to device security, we announced a couple of weeks back a new service that is coming up, which is a device provisioning service, which allows you to bootstrap at scale devices which you would otherwise have to go in and put in a key and then make sure that it is secure. You can use a device provisioning service to actually do it for you at scale. Of course, there is policy-based access control also on the tokens that go on devices. That's another feature built into it. X509 mutual auth, I talked about it. And finally, we also have a bunch of work that we are doing to ensure that the silicon that you put on your devices is also secure. So a couple of weeks back, we announced a bunch of hardware partnerships with a bunch of different companies, and I'll talk a little bit more about that, including ST Micro and Micron and Spirus, essentially allowing their silicon to work with our device SDKs so that their security that they provide at the silicon layer can be used as an anchor of trust for the cloud. So to that point, the key requirement for that layer, at the layer of silicon and hardware, is that it should be something which you can bootstrap easily. It should be something which you can put into your device at a low cost, right? So that's one. You should also be thinking about it as part of your device, not as an add-on. It has to be just part of the silicon that you put together. And what we have there is called the Device Identity Composition Engine. Yes, it's called DICE. And so this is a standard that we are pursuing in TCG. The goal of this is to have a very lightweight identification of the device based on some silicon gates on the device. So it gives you device identification. It also gives you attestation of firmware. So if you have firmware which on the device, what you do is you take some measurement of the firmware, and based on that, you generate some keys, and if that firmware changes, you can detect that in the cloud. So DICE provides you that with a very low-cost way, based in silicon, based on the gates which are implemented on silicon, and many of the products out there, like ST Micro's products, they actually support this. So we are pursuing this, and you will, in the coming few months, you will see more and more activity around it, meaning more partnerships, more newer features around this. If you want to understand how this whole thing works, ak.ms /IoT device is the homework for you. Go in and read that blog, and then it gives you a bunch of different pointers to documents. Okay. Then, if we have to say that we are doing end-to-end IoT security, we can't just stop at the features that we, as Microsoft, provide you for the cloud, for connectivity, and for the device. We also have to include the whole ecosystem in it, right? So what happens if that device is manufactured by somewhere where they're not following the best practices that they should follow? So for that, we have put together a bunch of best practices, and we have divided into roles. The roles here is who does what in this IoT ecosystem, right? There are people who actually manufacture hardware devices. There are people who do solution development, so putting the software around it. Then there are people who actually take that software and take those devices and deploy them in buildings and industry. And then, of course, long term, there are people who actually deploy and operate this for the long-term life of the IoT infrastructure. So what we have done is, for each of these roles, we have put together, based on conversations with customers and contributions by them, put that together as a best practice. For example, if you're an IoT manufacturer, a hardware manufacturer, and if you're developing that little device, if you do not need that USB port on it, why should you put that port on it? Simple things, but those are attack vectors which are known to be used by attackers. So that's something that we do. Similarly, there are a bunch of different best practices. Here is a URL which you could go in and get more information on. Okay. We didn't stop there also. This is an ongoing work. Remember, IoT security is always a journey. So we are continuing doing things in addition to what we do right now. So what we are now also thinking of is, you know what, if you have an IoT infrastructure where you have the cloud, you have connectivity, you have devices, and in the devices all that complexity is there, how can you actually have somebody look at it, evaluate it, and give you what are the different threat vectors that are part of that whole ecosystem, and give you an evaluation. So for that, we have a bunch of different things that we've done. Essentially, we help you reason through threats. What are the IoT-related threats, not just the IT threats, but IoT-related threats. I'll talk more about that. You review your consequences. If an attack happens for those threats, what are the consequences? What are the bad things that will happen? You review your evaluation strategies. I'll go into more details there. And then you choose the right partner. You choose the right third-party evaluator to help you with that. Okay, so I'll give you a link to this document subsequently, but this is just an example of the threats. We actually used the existing threat models out there. So we used the one which has been designed and developed by the European community. It has about 250 or so threats for IoT. And we actually went in and looked at all the threats and said, what are the things we can do to help with that? So that's something that you'll see, and I'll give you a document link there. Then you go in and look at what are the different consequences to my company. There's loss of control, financial loss, and so on. To my customers, compromise of privacy and disruption of service. And to infrastructure, including what happens if bad things happen and there is life involved. Right? So you evaluate all of that, and then you go in and pick up the right evaluation strategies for your IoT infrastructure. And you just don't run it at the same time. You evaluate where you are in your journey of creating that IoT infrastructure. If you're designing it, there are a separate set of things. If you're deploying it, there's a separate set of things, and so on. And so we give some guidance there. But then we also go in and the URL there gives you a lot of guidance there. And then you go in and you select the right partner. On that URL, you'll see this list of partners as well. These partners will help you evaluate security for your infrastructure. But again, we did not stop only there. We went a little bit further there as well, and we are now driving a standard at IIC, which is the Industrial Internet Consortium. This standard essentially defines a maturity model for security. And I'll just quickly go over that maturity model. Imagine that you are at level 0, which means nothing has been evaluated. Level 1 is some encryption, some kind of authentication, etc. And level 4 might be a real-time monitoring of what you're doing, right? What the infrastructure is doing. So what we are defining here is, and this is just an example, what we are defining here is these levels of security, maturity, which you should be aiming for. Now, we do understand while everybody would want to be at level 4, but cost versus effort might dictate that you probably would stop at level 3 or level 2, depending on your scenario, right? So as part of the standard, we'll also give some guidance in terms of what are the different things you should do if you are, let's say, healthcare scenario. And so somewhere here, maybe these levels are sufficient and appropriate for you. So this is, again, work in progress, and we will be announcing this in this summer, coming summer, where through IIC. And this is really a consortium of about 25 or so different companies. We are all working together to make this possible so that IoT infrastructure together can become more secure. So that actually brings me to the end of my talk. A bunch of links over here. We have documentation for how you configure your IoT infrastructure securely, but also we have a lot of documentation in terms of how you actually think about security end-to-end for your IoT infrastructure. With that, thank you very much. I hope you have fun for the rest of the time at the conference. Thank you.